Hello, welcome back. Welcome back. So we are in the another border world again. So we are going to be doing some stuff today. So yesterday we built the basics of this base. We have a steam generator. We have some basic tools over here. I've done the math. I've done the arithmetic, and we are going to need approximately 30,000 units of stress capacity on board the Nether Star. Well, since then, I've done better arithmetic, and this is wrong. We are only going to need about 1,000 units. So, a steam generator is no longer a question. It is, like, required. We need a steam generator. For the water, I'm thinking maybe a mod, like an infinite water source mod. I'm not exactly sure what to do, but, like, it's not optional. We need a steam generator. Gone ahead and installed the Ender transmission mod. This is what we're going to be doing right now. Today, we are beginning the process. We're building a drone. We're going to be programming the first computer. Well, to actually scan for the terrain around it, which we need to pathfind, we're going to be using a optical sensor, which tells you the block, pretty much how far the nearest block is. It's basically a raycast on a spinning thing. So it's going to be a spinning raycaster telling us about the terrain around us. We're going to talk more about how it works. But to do this, the first thing we need is ender power. I actually ended up not needing ender power for the drones. But there is another reason that you'll be seeing later where I do need ender power. So, you know, we still need it. We need 25 mechanical crafters. If you guys don't mind, I'm going to skip over a lot of materials gathering in this video. The point of this video is about making the drone. It's about making and programming and beginning the engineering of this challenge. Not so much about getting the materials. You notice in the last video, I focused less on me actually building, or so just my conversations I was having. This is a engineering series. Like, I'm engineering a bunch of things. It's gonna take a while. No shit! God damn it! Oh, I just spilled coffee everywhere. Fuck my life. Okay, that's all cleaned up. So there's a bunch of other stuff I wanted to do, like get better pickaxes and a tree farm. Oh man, just thinking about it. That would be so nice, a tree farm. Here they are. 27. We only need 25. Alright. It's all connected. So, this is a functioning mechanical crafter. This is just the crafter. We also need the materials to craft. So what are we doing? Well, we're building 2 NO2 transmitters, meaning we need 2 of everything you see. This is going to be very expensive, so I guess let's just go get some ender pearls. We need 14 ender pearls. Oh, wither skeleton. Wow, I was not expecting that.
Adapted. Now, notice the Copyright Act says a derivative is transformed. The discussion, that's merely the beginning of it.
So we have the 14 ender pearls that we need for the 2 ender transmitters. Now we need to go to the fortress, which is over here, and get the blaze powder. What's up, man? Come on, guys. Let's go. Now I'll go some obsidian, I guess, because we're in this biome. Then we'll go back to the overworld. We're gonna put you like this. Put you like this. You like this. You like this. And we want to make. Oh, we need 2 precision mechanisms. I hate my life. Deployer. So to make a precision mechanism, we have to do a sequence of events. We have to make 4 of them. And what we're going to be doing is we're going to be building these servo motors. Wait, can I not make them? No. No, what do you mean? No. Nothing in this mod is craftable. Here we go. 2 ender power transmitters. Hell yeah. Let's go ahead. This was my first crude attempt at the LiDAR scanning technology. As of now, it's much better than this, and it works completely differently. So, over the next day or so, I started doing a number of prototypes in Creative Worlds. This is just one of the later ones, but I cycled through potentially 10, 12 different designs before settling on the final, which is definitely not this one. I even made this successful prototype, which was capable of maintaining its own altitude, but it was really heavy, didn't have any reaction control, and as you can see, was slow to respond and sort of clunked around at altitude. It was also very unstable and prone to mass fluctuation. It was at this point that I decided to switch to a solid state approach. Making the Kite stuff just took up way too much mass and space to justify its instability and lack of thrust. Create parts are changed via the rotating of an actual physical shaft, and you can only update that once every about 400 milliseconds, which for stabilizing yourself, altitude and especially orientation wise is not an option. You need to be able to update faster than that, especially with a low mass ship. The solid state thrusters let us update about 20 times per second, so we don't have that problem anymore. Eventually I settled on this. This is the final design for the drones. It doesn't have the LiDAR scanners on it, but over the next few days I began programming this. My hand, so that negative Z is in that direction. Now my index finger is facing towards the sky, and my thumb is facing directly towards my computer screen, which is directly in front of me. So I can now see the X is going to be positive for its position. So it's going to be positive X, and it's going to be negative Z. Hello. This may be hard for some of you to understand, but I'm not purely digital. I do also have a physical corporeal form. So we are talking about the design requirements for the ship today. So what we're seeing now, what you're seeing and what you're going to see, were all designed in the past. That's a crazy concept. This all happened, not now, not yet to happen, but actually happened before now. We're going to be talking about the specific programming requirements. So if you're not interested, I don't care. 90% of this is programming. A huge amount of this series going forward is programming. So if you don't care, you might as well just skip now and call yourself a LARPer. All of the programming you are seeing is written in Lua, which is a problem. Lua, for all of its upsides, which is a tremendous amount, it's a very good language, does have one issue for me. It's dynamically typed. Dynamic typing means it doesn't have a strict type of object, which imagine you have a variable like in math. X equals 2, for example, right? An algebra variable just represents something else. What is X? Well, you may say it's a variable, but I mean, what does it represent? It represents a number. X is representing a number. The type of X is a number. If X equaled hello there, that would be a string. A text is a string in programming. So the type of it would be a string. In Lua, the interpreter dynamically sort of guesses, or not guesses, assumes what it is. And it's right a lot of the time. The issue is, if you try to do any operations or use those variables, especially in functions or via transformations, sometimes you can lose that type meaning. The type of an object only exists in your head. For a program like this, which it's important that it has as few hard failure points as possible. It is really important that we eliminate that. For that reason, we're going to be using a language called TypeScript. In TypeScript, whenever you define a variable, you also define its type. For example, it would be X number equals 2, or X string equals hello there. It always defines the type first. Type safety is very important for a mission critical system. We are also to not allow type issues. The as operator cannot be used. So we cannot use something as if it was something else. We cannot use a string as if it was a number, because that effectively causes the same dynamic linking problem. If we have to do that, then we need to refactor that code. For every logical branch, there must be a contingency if it's not followed through. What I mean by that is, let's say we have the navigator and we check if the thruster exists, then do thrust, right? What we also need is a contingency. If the thruster doesn't exist, do some backup thing. Every logical pathway must have a backup path if it doesn't get followed through. No heterogeneous arrays or tables. Basically, an array is just a bunch of variables just in a list. You can imagine it like, it's not really how it is, but it's sort of like that. And we can't mix types. For an array must only be numbers or only be strings. We cannot have an array that's numbers and strings. No circumstances should the any type be used. The any type is also a cop-out, and any type will accept any type, which we almost never want. We do not want that. We want to explicitly type things. There is an exception. External libraries like the ship library that we need to interface with the ship, we have to use Lua. And to use Lua, we have to use dynamic typing. So we have to make a wrapper that does use the any type. But for those special occasions, like I said, it is imperative that we make a wrapper and container for the object so that for as much use as possible inside of the actual script, it is typed. Because of this, it is important that we use external libraries to the minimum. Try not to use external libraries. Avoid creating short-lived objects inside loops. We cannot create a variable inside a loop, reference it, and then in the next loop, recreate the variable. All variables should be defined outside of a loop and then assigned and changed inside of the loop for garbage collection reasons. No recursion at all. Again, this is going to avoid something called a stack overflow, where the memory buffer overloads. There's too much stuff in there. If we have a function that does a thing and then calls itself, like a hill finding algorithm, no, we don't. We don't do that. We use a different method. For example, we set it so that we set the information that we want to pass down inside of a structure, and then in the next tick, the next update event, that structure will be executed again with that updated information. This means the function will only get called once per tick, and that it will be updated with that information. So this makes the timing more consistent as well. Nesting is whenever you have a function, or more technically a scope inside of another scope. We can only do this up to 2 times, meaning if we have a function, we can have an if statement in there, and then inside the if statement, we could have another if statement, and that is the absolute maximum, nothing more than that. Priority requirements. These aren't the programming requirements, these are the requirements for the design. So each craft has 3 priorities and executes them in this order. First priority is the aviation part. The craft must be able, before anything else, to maintain its own stability. The second part is the navigation part. After it has been able to maintain its own stability, it can then focus on navigating, either via pathfinding or following waypoints. And then communication. Craft are capable of communicating to each other via a WebSocket. Craft should only do this if they have both been able to aviate and navigate. So aviate, navigate, communicate is a list of priorities for the craft. Anything else can happen after, but most flight computers should not have an extraordinary amount of processing happening on the 4th step. It should pretty much only be doing those 3. If there is another rule, is that if a serious amount of data is needed to be processed or done on that miscellaneous step, that should be outsourced to another physical piece of hardware that is physically, mentally, and programmatically separated from the flight computer.
But there we go. So you'll notice that it's actually pretty stable along the axes. There is, of course, like obviously, the rotational axis, well, the axes, are the biggest issue, and I've been trying to tune them for hours. Now, listen, it's not the best, but it was a lot worse, okay? It was a lot worse, and this is the best we're gonna get.
I rewrote the entire rotation code, and it's much better now. So there's issues before, like the quaternion multiplication was just like flat out wrong. So you can see here, if I go ahead and right now I just have it spinning in a circle, I just tell it to not spin in a circle and just maintain a steady 100. You see here, 160-degree angle. Look at that. Virtually no movement at all. Literally, it's literally just like, look at that. You can see it overshot a bit, went back. That's a simple tuning issue. But look at this. This is like, it's like once it's at the altitude, I actually cannot see any rotation right now. It is actually dead on it. This is perfect. And it can also rotate very quickly. You see, if I make it rotate much quicker, it's capable of rotating quickly. Look at that. It's actually rotating pretty fast right now. Now, I think I am going to do some math to counteract the force of gravity in the calculation for the PID loop for position, just to make that a little bit more stable, but I don't really think I really have to do that much. Plan B. What you are looking at are 3 photon blasters, which is exactly how powerful it sounds. Literally anything touches this path, it will explode. Like a block, anything. Not drop like that, but like this is just a path of instant death. And the photon blasters are built with a mod specifically designed for Valkyrian skies. And plus, all it takes is 2 alternators to power Well. Nether Star. Nether Star to make 2 of them. Is that bad? That's not that bad. That's actually not that bad. Oh. They would be nice. I get 2 Nether Stars, I would have 4 photon blasters on drones. Position them cleverly. Oh, I might have to defeat 2 withers. What is up, my prankster gangsters? Forgot to inform you we are now building an XP farm. Man, I haven't been in this world in a few days. I've just been in creative worlds the past week. I don't think I opened the world yesterday. Okay. Oh, I got that hand looking mod that I had before. Okay, dang. So we need to make for the farm. Here it is. It's Kindle Bubble. This is a shitty ass name. But this is the guy I followed last time for the last one I made. This cobblestone generator, it's great. It is really good. It takes 1,000 stress units, but it doesn't disappoint. It gives you a shit ton. Like, it actually gives you a shit ton of cobblestone. This is what we're gonna be using. It's pretty simple, and I literally will never need this. This is an absurd amount of. Look, look at this. Look at this. Look at this. It's a huge hole in the ground, industrialized with wood to structurally support it, and with cobblestone in the walls for an aesthetic decoration, and a solid boundary against the outside cave. I think it was copper. Dude, I have so much coffee. Dude, I had so much coffee today trying to programming this. I'm actually shaking right now. Like, I can't hold my hands still. I put weight, dude, I feel like God right now. Spinning clockwise, pushing things over here, and it's not gonna be able to go through this tunnel because it's all cobblestone. And what happens is it's waiting for it to be cooked into stone. Once it's cooked into stone, it'll be let through, and then there we go. So that's basically the plan, is to cook everything into stone, and then it won't over coming in through here after. All right, so we have this. Now we have to make the haunter. Haunter is basically that. We're basically just making this again.
Or increase tariffs. Come on, people, let's think bigger. It can be both. Michael specifically has been in the DIY doghouse, apparently picking clean the carcass of its recently.
I got 5 diamonds, and I made the mad axe. No. Guys. The Mad Axe has met a terrible fate. The Mad Axe that I've had since the very beginning. The most important tool I made. I remember I was struggling so hard to get progress done because I couldn't get anything or find anything, so I had to get fortune. And the Mad Axe had that. I'm afraid that the extremely important piece of technology is over. A creeper approached me. I accidentally pressed both Q and the W key on my keyboard simultaneously. I tried picking it up, but my inventory was unfortunately full. The creeper blew up before I could clear it. And the Mad Axe has been destroyed. This is very sad. That was, I think, literally my first diamond pickaxe of the world. That I just kept keeping alive with. I kept putting diamonds in it to stop it from breaking. And it's gone now. So that's really sad. Yes! Yes! We got our first silverfish! Yes! Alright. Let's go ahead and patch up this hole over here. I guess there's probably some structure I can go find the books at. Please tell me that's not just a village. Oh, God, please. I think I found a structure. I think it might be a village. Come on, please. Look at it. Okay, I can't tell if this is just a new looking village. Please have books. I've been looking for like 30 minutes. Yo, what the hell is that? I'll take the redstone. It's one of these! Oh my god! It's this! Oh my god, one of these was literally right next to the base. Oh, the base all the way over there. Oh, 39 blocks away. Hell yeah. Alright, you have Unbreak 3. I'm actually gonna walk this. There's a cat over there. I found one of my cats near these areas before in the last playthrough. I think it only makes sense if I do the same. Come on. I am really cool. Yeah? I'm really cool. This way. Toward. God damn. My power went out. I don't know why. But my power went out. So, you know, that's great. Goddamn fun. Lithium! Holy shit, yes. Lithium, oh yes. Lithium is very valuable. Holy shit. This is actually unfathomably good. We need a ton of lithium. I actually didn't move a step. Okay, I'm just running at you. Get over here. Get over here. Get over here. No. I'm recording, mainly tomorrow. Get in here. Get in here, guys, come on. Yo. Oh, dude. Oh, come with me, bro. Come on, let's get out of here. Let's skedaddle. So, no, the matchstick. All it needs now is mending. Reborn! That fat reborn. Mad Axe 2.0. All that's left now is to get a better efficiency. Efficiency 5, Unbreaking 3. The Mad Axe is reborn. Thank you for watching this Talking Lot production. I see YouTube, my followers on YouTube, my 38-ish subscribers. I do enjoy you watching this production, this film, if you will, and I thank you, and I will see you in the next production / film that I construct.